Hi there, welcome to N7.1. These are the division strategies. There they are. So there's little tricks that we're going to learn for multiples of 2, 3, 4, 5, 6, 8, 9, and 10 that can help you do division faster without actually using a Dave. Okay, so we're going to find out what those strategies are and be able to put them in our own words. We're going to apply the strategies when we see the questions, and we're sorting them into Venn diagrams, which looks like this. Okay, and so any numbers that you have in common would go here, and numbers that aren't in common would go here. So those are Venn diagrams. Determine or validate the factors. Factors are the little guys that you multiply of a number by applying the strategies for divisibility. So if you apply, well, we'll do an example later. Okay, explain the result of dividing a quantity of 0 by a non-zero quantity. So if you're dividing 0 by 7, I have $0, and I'm going to split my $0 evenly between 7 friends. Each friend gets nothing, right? And explain why division of non-zero quantities by 0 is not defined. So this is going the other way. If you have $60, and I think I have a video in maybe the grade 6, I'm not sure, that has an explanation of division by 0. But anyways, here it is. If I have $60, so there's my 20s, okay, and here's me. Looks like me, hey? Okay, I have $60, and I'm going to divide my $60 and give it away to all of my friends, which is this many friends. I have 0 friends. Poor me. Okay, so if I give my $60 to 0 people, does that mean that because there's nobody getting my $60, it just comes back to me? Because there's no one to take the money. And so dividing it by 0 into 0 groups would mean that it doesn't get split up. There's nothing here, right? And so the money just goes back to me. So that means that 60, when you divide it into 0, would mean that I still have 60, right? But this can't be true because 60 divided by 1 is 60. And if I get all the money, well, that's one group. It's me. I get the money. And so we can't have 2 equations that equal 60. And so the mathematicians of the world have just agreed that anything divided by 0 is called undefined. You might see it as a U on your calculator. You might see this on your calculator. It might actually say the word undefined, meaning there really isn't an answer. Okay, and there's all sorts of math jokes about dividing by 0, and I've got one coming up. I'm here to tell you they're really not that funny, but I'm sure math people think they're pretty funny. All right, let's have a look. Okay, so here are your rules. The number is going to be divisible by 2 if it's an even number. So if it ends in 2, 4, 6, 8, or 0, which in this case it does. So this number is divisible by 2. And what they mean by divisible by 2, if you used a Dave, I'm just going to change color here. If I used a Dave and I worked it all out, I would not have a remainder. Every number in the Dave would have somebody above it, and there would be a remainder of 0. So it means that it goes evenly. Okay, the rule for 3 is actually quite handy. If you can add up each digit and get a multiple of 3, so in this case they added 2 and 7, which equals 9, and 9 is a multiple of 3. right? 3 times 3 is 9. So because 9 works, that means that 27 works. In this one, they added 2 plus 4 is 6, plus 0, still 6. And 6 is a multiple of 3, so therefore 240 is a multiple of 3. We'll just try a non-example real quick. Okay, 2 plus 4 is 6, plus 5 is 11. 11 isn't a multiple of anybody, right? So it's definitely not a multiple of 3, so that doesn't work. 245 doesn't work. The rule for 4 is that the last 2 digits of the number have to be divisible by 4. So in this case, it's a little easier because we know that 44 is divisible by 4. It's 11, right? And so 1044 works. We can look at the 52 and think, well, that is 40 plus 12, and 40 is a multiple of 4, and so is 12, so 52 has got to be okay. 2500 will work because the zeros actually represent 100, and 100 is a multiple of 4. The rule for 5 is the easiest one. If it ends in a 5 or a 0, it's good to go. The rule for 6, it just has to be even, so it has to fit the divisibility rule for 2, and it also has to fit the rule for 3. So all these digits added up must be divisible by 3. So 4 plus 8 is 12, plus 1 more is 13, 14, 15, 16, 17, 18. So this number will work for 6. The rule for 7 is not in your curriculum, but you can have a look at it anyways. It's a little more complicated. I can see why they left it out because it's probably just as easy to use a Dave. But they say that if you take the last digit, which is 5, and double it, which is 10, and you subtract it from the rest of the number, if you get that answer is divisible by 7, which in this case it is, right? 49 divided by 7 is 7. So that means that the rest of the number is divisible by 7. So you don't really need to know that, but it's there if you want to challenge yourself. The rule for 8, I find this one kind of useless too because you need to know 3 digits. Well, I don't know if 8 is going to go into 529 or whatever. Probably not because it's not even, but let's say 530. Well, this one's easy because does 8 go into 53? No. And so if we typed it in on the calculator, 530, we get some wacky answer like 66.25. So if it's a multiple of 8 with a 0 on it, like this, divide by 8 is 60, so that would work, right? But in general, you're not going to know your 8 times table all the way up to 3 digits, all the way up to 999. So this one doesn't really do us a whole lot of good unless it's a multiple like this, a multiple of 10. The 9, let's have a look at him. The digits, it's kind of like 3, except they have to add up to 9, or have to be a multiple of 9. So 27 works because 2 plus 7 is 9, and 9 is a multiple of 9, so that works. 891, 8 plus 9 is 17, plus 1 is 18, and 18 is divisible by 9, so 891 is as well. There are your rules. Now you can Google these and print off a chart, put it in your notebook, keep it while you're doing this outcome, because it's a lot to memorize, but I think the ones you need to focus on, you should know that even numbers are divisible by 2. The rule for 3 is very handy. You should know the rule for 5 already. And the rule for 9 and 6 is just the same as 3, so you should be able to memorize the majority of these guys. Okay, so here comes that Venn diagram. Create a Venn diagram that sorts the numbers below according to the divisibility by 3 and 4. So if we say this side is going to be divisible by 3, this side is going to be divisible by 4. So where do you want to put 12? Well, 1 plus 2 is 3, and 12 is also divisible by 4, so it has to go in the middle. 32, 3 plus 2 is 5, so it's not divisible by 3. It is only divisible by 4. I'll circle these. 60. 6 plus 0 is 6, so it's divisible by 3, and it is divisible by 4 as well. 4 times 15 is 60, so 60 can go in the middle. 24. 2 plus 4 is 6, so it works for 3 and it works for 4. 3,140. The last two digits are divisible by 4, so it works for 4. 3 plus 1 is 4, plus 4 is 8. And that is not divisible by 3, so that one is only going to work for 4. The last one, 99. 99 is 18, so that works for 3. 99 is not divisible by 4 because 100 is divisible by 4. So obviously 100 minus 1 is not going to work. So it is only going to go there. All right, a factor tree. I think there are a few assignments on the SCMA that ask you to do a factor tree, and I wanted to show you a couple different ways to do factors. So factors are the little guys, the green guys, that are multiplied together to get the big number at the top. And the way you want to do a factor tree, there's tons of different ways that you can do them. I kind of like this method because it keeps us more organized. So when you have a number like 108, you can look at your 8 and know right away that it is an even number, and so it's obviously divisible by 2. So that's what this person started with. And 100 split in half is 50, so that's where they got this from. And 8 split in half is 4. So 2 times 54. Then they picked 3. I might have picked a 6 or a 9 or something. But they picked 3. 3 times 18 gives us 54. So 2 times 54 gives us 108. And that's how our factor tree works. So the 18, they split into 3 and 6. And every time they get a prime number, they circle it. That's why the 2 is circled, because it's prime. Prime means it doesn't have any factors other than itself and 1. That's it. And we never ever use 1 in a factor tree. And so once you get to a prime number like 2 or 3 or 5 or 11 or 13, those kinds of numbers cannot be broken apart anymore, so we just circle them and we're done with those guys. So the 6 can be broken down further into the 2 and the 3. Now if we take all those prime guys, we have 3 3s and 2 2s, right? 1, 2, 3, 4, 5, right? All of those factors multiplied together give you that number at the top. Okay, so if it says show the prime factorization of 108, you would draw out your factor tree, get it down to all prime numbers, put them all together in a multiplication statement, and that gives you your guy at the top. So there's another task that you might be asked to do with factors, and that would be list all the factors of 108. And so we've done this part with the tree. We knew that 54 times 2 is 108, and then we got it split down into the prime factorization. But what about numbers like 4 and 9 and 6, right? Those, I guess we have a 6 here, but we didn't have a 4 or a 9 in our factor tree. But you do realize that we can take this 2 and this 2 and put them together. 2 times 2 is 4, and the rest of the factors, 3 times 3 is 9, times 3 more. Okay, so you can group your factors in different ways. You're still going to get 108. And so that's where they got the 4 times 27 is 108. When I list factors, I like to go in order. So if I was doing 108, I would say, well, 1 times 108 would work. I know 2 will work because it's even, and then eventually you could figure out that it's 54. 1 plus 8 is 9, so I know 3 will work. I know that 8 is divisible by 4, so I know 4 will work. 5 is not going to work. right? So I'm not going to put 5 right here in my list because 108 does not end in 0 or 5. I know 6 will work because I can double my 3 and split my 36 in half. That concept of doubling and halving works really well when you're listing all the factors. So just like here, they doubled the 2 to get the 4, and then they took half of 54 to get the 27. So it works pretty slick. Okay, 7 does not work, 8 does not work, but 9 works. And again, I could triple this to get my 9, and then split this into thirds to get my 12. 10 does not work because it doesn't end in 0. 11 does not work. And so there are no numbers between 9 and 12 that are going to work, and so I use this little arrow quite often to show that I've kind of closed the gap. I've used all the numbers in between 9 and 12, and so my list of factors is complete. Okay, here's the jokes about dividing by 0. Oh gosh, they're so funny. Okay, so in this man's hands there are $0, right? If he divides it by 4, he's got nothing. Okay, and so let's imagine that he has 0 carrots. Okay, and he divides his 0 carrots and gives it to each of these rabbits, so he gets nothing, and he gets nothing, and he gets nothing, and he gets nothing. And that is why they're all sad. So dividing 0, you can divide 0 into as many groups as you want, right? I could have 50 rabbits here, wouldn't matter. They would all be unhappy because they're all getting 0. So you can divide 0 up however you want. You can give nothing away as many times as you want. Okay, you can share $0 with your friends anytime you want. It just means that everybody gets 0. Now, on the other side of things, you cannot divide by 0, and that's what this is showing. So let's say there were 8 houses here, right? And we tried to divide them by 0. So what happened to the houses? We can't keep them, otherwise there would still be one group of 8 houses. Or there would still be 8 houses. And so scientists always kind of laugh and say it creates a black hole and the houses have to disappear because there's no other explanation for it. So this guy's awesome t-shirt, it's all fun and games until someone divides by 0 and then there's like an explosion or something. All right, happy dividing.